Hello, this is Math 2270 coming to you from the College of DuPage during the summer of 2020, and this lecture is entitled Solving IVPs Involving the Heaviside. Again, what we're doing is we're starting with an unknown y of t with a differential equation with initial conditions. We're going to apply the Laplace transform. We change that differential equation into an algebraic equation in y of s. We solve the algebraic equation for y of s, mindful that I have to be able to invert the transform when I do that, and then I invert the transform and I have my solution to the initial value problem. But this is complicated because in addition to what we had to do before, we have to be mindful of the conventions associated with the Heaviside function and its inverse transform. So here we go. This is a problem. I'd like for you to solve this initial value problem. You know what to do. Let's see how you did. First thing we need to verify is that the shift is correctly represented, and in fact it is in this problem, and so both are being shifted to. That means I can directly take the Laplace transform of both sides, getting this, and I substitute in my initial conditions, getting this, and that is s plus 2. It's cut off a little bit, and so now I'm going to solve for y of s, and I'm mindful that I have to groom y of s, so it is something that I know how to do the transform of. Now when I get down to this step, I realize that this is really going to be just a Heaviside function whenever I invert the transform, and so that tells me that I'm really going to be focusing on figuring out what f of s is and what g of s is in such a way that I can do the transform. So that means I'm going to be doing partial fraction decomposition on f of s and g of s. You should verify that this is what you get, but this is what you get. And then I know these are groomed in such a way that I know how to invert these transforms, and that means that the lowercase f of t is going to be this, and the lowercase g of t is going to be this. Now let's return to the problem we're really trying to solve, though, is this is what our y sub s was moments ago, and so y of t is going to be f of t, which you see here, plus a Heaviside function shifted by 2, and this is going to be times g of t minus 2, which is going to be 1 over 11. This is e to the minus 2 times t minus 2. This is e to the t minus 2 over 2 cosine square root of 19 over 2 t minus 2 plus 5 over root 19 e to the t minus 2 over 2 sine root 19 over 2 t minus 2. That's the solution. Here's another problem for you to solve. You know what to do. Let's see how you did. Now the first thing we want to do is verify that in fact the shift lines up, and in fact in this case it does. Again, the function that's being shifted is cosine of 2t in this case. So now I can take the Laplace transform of both sides, and this is what you should get once you do that. And then I substitute the initial conditions in, and I solve for y of s, being mindful that I have to have an expression in y of s that I can invert. It turns out, after some thoughtful algebra, this is what I can get. So y of s is equal to 1, which is just going to be, that's a constant times f of s. This is just going to be a Heaviside function, and I know what that is. That's just going to be minus 4. So I'm going to focus on just saying, well, what happens here? And so f of s is going to be this, and the Heaviside partial fraction decomposition ends up being this. And then when I invert this f of s, I'm going to get this. And again, you should verify that you understand all of these steps. Now returning to what y of s is, and here I'm just distributing the f of s across there. So I get this. So that means the y of t is going to be f of t, which is just this thing up here. But then this is going to be the Heaviside step function shift 6. And then this is going to be f of t minus 6. That's going to be 1 over 5 e to the t minus 6 minus cosine 2 t minus 6 minus 1/2 sine 2 t minus 6. And then it's going to be minus 4. Here's another problem for you. Let's see how you do. You know what to do. We will see how you do right now. Okay, so this is what happens. And we start checking in the shift again. This is a shift of 1, so that's all good. We take the Laplace transform of both sides, getting this, and we are going to solve, and we substitute in the initial conditions, then we solve for y of s in a way that's being mindful. But this time, what happens is I end up with an f of s, a g of s, and an h of s. I have to know how to take the transforms of these. So first thing I do, partial fraction decomposition of f of s, g of s, and h of s. And then I think about what the inverse transforms are of these, and this is f of t, g of t, and h of t. But then I return here, again I distribute the f of s across there. And so this is what I'm going to be inverting using those values. And so I get y of t is equal to this. So that is 9 times this f of t expression here. Heavy side shifted by 3, and that is going to be this, but I'm going to be putting t minus 3 everywhere where I see a t. And this is going to be 4 times the heaviside shift function 1, and this is going to be g, which is here, and instead of having a t, I'm going to have a t minus 1 everywhere, plus, and then this is h of t. Let's do another example. And here, the right-hand side is a step function this way. You know what to do. Let's see how you did. Okay, the first thing one has to do on this one is model g of t using step functions. You might remember, it's probably about 5 videos ago we talked about how to do this, but this is g of t represented with heaviside functions, and there's a shift of 10 and a shift of 6. And then I have to line up and make sure the shifts are the same for the functions that are being multiplied by here. So there's some addition and subtraction that happens here to align the shifts. Here's a shift of 10, here's a shift of 6, and when we simplify it, we get this. So you see in the first one, the function that's being shifted is t plus 4, being shifted 6, and the second one, being shifted 10, is minus 6 minus t. But now I'm prepared to take the heaviside step function of both sides, and I do that, and I get this, and then I simplify it a bit, and I get this, and I continue simplifying it up here, and I get this, and so on and so forth, and finally I ended up with this as y of s, and so I have to now groom this so I know how to take the inverse transforms. So you see what's going to happen here is I can say that it's going to be this, this, this. Again, I have 3 separate functions, but these are functions that I know how to take, both find the partial fraction representation as well as know how to invert them. So this is f of s, and there's the partial fraction decomposition. This is g of x, there's the partial fraction decomposition. And this is h of s, and there's a partial fraction decomposition. And I know what f of t, g of t, and h of t are. So now I go over here and remind myself that this was the thing that I really have to invert. So when I invert this, again, these are just going to be heaviside functions that will pop out. And so I can use the linearity properties of the inverse transform to do this. So what I get is my solution is y of t is equal to 2f of t, and f of t was over here. And then this is going to be minus h of t, and h of t is over here. And then this is the heaviside step function 6, and that is 4f of t minus 6. So I have to put t minus 6 into here instead of t. This is g of t minus 6 I put in here, and the heaviside shift of 10 is 6. That was f of t, and now f of t was here. That is a shift of 10, and g of t is here. That is also a shift of 10. But that's instead of solving three separate initial value problems that you can't weave together. So this was a powerful approach. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourself and of each other. God bless you all.